the standards for software, even for a startup, are much higher now. You just can't have shitty software, even if you solve like some unique novel pain point. Customer expectations are very high, and that's going to pull the field forward.
Welcome to Manifold. My guest today is Omar Shams. He is an AI founder who recently sold his company to Google. His position at Google currently is as a lead on the AI software agent developments. And I'm really looking forward to talking to him because he is not only a leading thinker and researcher in AI, but he has a background in theoretical physics. So Omar, welcome to the podcast.
Thank you for having me, Steve.
And we are broadcasting from the Equinox Hotel in Hudson Yards in beautiful New York City. Omar splits his time between San Francisco and New York, and I'm here giving a talk on AI. So we're lucky to be able to get together.
Thank you.
So Omar, let's start with your background. So you went to Carnegie Mellon, studied math and physics, and then you went to grad school at Rutgers to study string theory. And so talk a little bit about what the world looked like to you when you were in your early 20s and when you actually started thinking about AI separately from physics.
Yeah, great question. So I think much like you, my first love was definitely physics. I was obsessed with that. I remember reading about the twin paradox in high school, actually, when I was 15. And I remember looking at this little cartoon in the back of my physics book, and it had, one twin go out and come back, and then his twin was much older. And then I remember thinking, like, this is made up, right? Like, this is a joke or something. And then I went to my teacher and I was like, hey, but this is fake, right? Or this isn't real. And he's like, no, it's real. And I was like, what? And it was like finding out that magic really exists. That was my honest subjective perception. And I was like, okay, I must learn magic. And so I did that for a good 10 years. My specialization at the time, I was Tom Banks student, and I ended up, dropping out ABD with dissertation, but was holography. And Tom, and I think Tom still works on this, is using non-commutative geometries to reconstruct things like, space-time. Like, could you go from a non-commutative geometry where space-time becomes actually this emergent thing, right? And the specific work I did was doing some stuff on, which I barely remember anymore, on conformal killing spinners. Spinners are kind of like the square root of vectors, right? And using that to construct the SUSY algebra. It was really...
SUSY means supersymmetry our listeners.
Sorry. SUSY meaning supersymmetry, which is an extra symmetry that, these spinners, which again are kind of like the square root of vectors, furnish. And then kind of towards the end, when I was, about to drop out, I got really into biophysics. And I need to be careful because people mean a lot of things when they say biophysics. So lipid physics and kind of the structure of that. I was more actually on the genomic side. So I did a little bit of genomics. And this is kind of not that surprising anymore. But at the time, one of the very first things I did was, okay, let me do a PCA on this human mitochondrial DNA. I think that was definitely a big part of it, like seeing that, the power of, machine learning techniques on these kind of data sets. As an undergrad, I also did some lattice QCD with, I believe, Colin Morningstar.
Yeah, I know Colin.
Oh, you know Colin? So
and Tom too.
Everyone. I did that for a summer, a nice summer with Colin as an undergrad. So that was probably my introduction to the field, but really my main introduction to doing this was my first job, where I built a music recommendation engine as part of this small company called Hi-Fi, which later was acquired by Block.
Okay, let's, before we let you leave physics, let's dwell on physics just for a little bit. I'm really struck by the story that you just gave about special relativity in high school, because I've had the same thoughts that, when you're a kid, if your brain is wired the right way, even just knowing a little bit of algebra you can rederive the Lorentz transformation, special relativity. It doesn't require any more than simple algebra 2 level stuff. And I actually have an old blog post where I say something like, how can a kid be well educated in the United States and not have been exposed, at least briefly, to the ideas of special relativity? Because it's such a glamorous thing, like Albert Einstein. And then, like, how could you not suddenly get interested in physics when you realize some very simple empirical input, like, wow, the speed of light looks the same to anybody, no matter what speed that person is moving, that observer is moving at. That simple observation then, with a little bit of logic and some equations, leads to, for example, the twin paradox that you just mentioned. So I'm just always amazed when I meet another smart, highly educated person. I'm like, how come you aren't more interested in physics? Like, didn't you see that part of the textbook you were forced to read in 11th grade or 12th grade where they explained all this to you? Like, didn't that strike like a light of fire in your mind? So you're like an illustration of the type of brain that I'm thinking of, and I don't understand all those other brains. So what do you think? Were you the only kid in your high school who cared about this?
Yes. Yeah, I think so. Yeah, I think for me, just the pleasure of, doing these math puzzles was kind of, one level of like enjoyment or intellectual satisfaction. But there was something about physics where it lit up this fire, or for me, it was very visual. Like there's this movie that was playing in my head when I would do physics problems. That was very fun. That was almost like an action movie playing or some kind of thriller. I don't want to over dramatize it, but really I get like visuals when I was doing this stuff. And I remember also in high school at the same time, I would catch clips, on like whatever PBS or whatever of like, a train moving with light and, someone trying to like flash light in a bag and like, what are the properties of light versus, matter and so on. And I just remember it was like very like compelling to me. Like, again, like discovering that magic is real.
Yeah. This is a big difference between physicists and mathematicians, because I think most physicists talk about something called physical intuition. And I think a big part of that is that part of your brain, I think for evolutionary reasons, is wired to actually simulate, maybe visually, the real world. And if you can tap into that, you can do very powerful things. So some mathematicians I know just laugh at Einstein's special relativity because it's so simple. The equations are so simple, and it's like, how can this be a big deal? But the depth of it is not those equations. The depth is the philosophical thinking or the physical thinking of, wait a minute, if Michelson and Morley did this experiment where they found no matter what frame they were in, they always measured the same value for the speed of light, that suddenly had incredible implications that you could actually get to with very simple math. And I'm sure Einstein was also, just from the thought experiments, Gedanken experiments that he always talked about, was very visual as well. Yeah. So later in our conversation, we're going to get to whether that kind of powerful thinking that physicists have, which is to integrate that kind of intuition, like, oh, what is a little ball rolling down a surface during gradient descent? What do we know about the way the ball rolls down the surface? How does that actually become useful in modern AI research? So I think that's something I want to try to get out of you. So let's go back to you decided that you wanted to get into technology. And so I think you just mentioned the first startup that you worked at, but I think you've worked at a succession of the top AI labs, right? You worked at DeepMind. Were you in London or?
I actually was in London.
Okay.
And I sat, just a few feet across from Demis and Benching.
What year was this?
This was 2018, 2019.
Wow. Yeah. I wonder if you went to my talk, because I gave a talk in London on genomics and AI. Yeah.
I just missed it.
Okay.
I was really excited, and I don't know, for whatever reason, I just missed it.
I have to tell a funny story about that, because I went to give the talk and I came to the building, the building in London, and is it near King's Cross?
It is near King's Cross.
Yeah. So I went to this
6PS.
Great building,
yeah.
Although I guess they later moved into an even cooler one. But I go to the building and they've got this whole itinerary for me, and I'm meeting with all these people, and it looks like a job interview. It looks like the kind of set of meetings that you have if you're interviewing for like a faculty job. But it also could be just like people who are interested in talking to me about research or something, right? So I wasn't really sure. But then, like, the very first meeting was with a guy called Pushmeet, who's now,
Push me.
who's now like the VP who runs like the whole AI effort, right? And AI research. And everyone that I met in every meeting kept asking me, are you joining our protein folding project? And I'm like, why do you think that? I'm here to convince you that you should all be working on genomics, not protein folding. Like, so we had a little clash, not clash, but just friendly. Like, I'm like, no, this is more interesting. And they're like, no, this is more interesting. And they kept saying, well, we all thought you were a job candidate because you're a physicist and you already work on DNA. So we thought you're joining the protein folding project. So that was a funny story. And like, now that I look back, I'm like, maybe I should have joined the protein folding project and been involved in Nobel Prize or something. So, but too bad we missed each other.
Yeah.
So what are your thoughts on DeepMind? Because, as you know, OpenAI got started because when Demis was involved in selling it to Google, maybe this isn't that well known a story, but Elon and a guy called Luke Nosek, who's another PayPal mafia guy, he's the founder of Giga Fund down in Austin,
I know.
They tried to buy, the story, they tried to buy DeepMind because they didn't want Google to have it. So they were at a party and Luke and Elon actually hid in a closet to get away from the noise. And they called Demis and they were like, whatever, Google's offering 600 million, we'll match that. Right. And then Demis, I think, according to the story, said to them something like, well, you can maybe raise that money, but you can't match the compute infrastructure that I'm going to get. And so he ended up going to Google. DeepMind became a subsidiary of Google, but then those guys were paranoid because they thought DeepMind was going to get way ahead and solve the AGI problem before everybody else. And that's why Elon backed the founding of OpenAI at the beginning to have an open, I'm putting it in air quotes because we all know what OpenAI is like now, but originally like to have an open lab that was doing AI so that Google couldn't just snatch the prize. Did you ever hear that story when you were working there?
I never heard that story. That is very interesting. I should say that just because currently I'm part of the Alphabet family, I'm going to deliberately avoid.
Yes. Don't say anything that'll get yourself in trouble.
Yeah. But yeah, it's an interesting story. I think that AI race is interesting for many reasons. So many reasons, philosophical reasons. It's forcing us to ask questions that we kind of were, put off for a long time, even existential questions, I think.
Yep.
But it's also interesting because I think there's legitimately two bottlenecks. Usually there's only one bottleneck, but there's two bottlenecks that I think vie for how big of a bottleneck they are. One of them, of course, you mentioned chips, but the other one is increasingly actually just energy. Like just raw power, like how powerful, how much power do you have, right? Yeah.
Well, when I talk about the US-China AI race, one of the issues that comes up, well, both of these come up. One is like NVIDIA versus Huawei for AI chips, but the other one is just like, how are you going to power these data centers? Like it's very tough to increase grid power supply in the US, whereas the first derivative of the Chinese electricity production thing is just going gangbusters. They actually add, I think the correct statement is they add the equivalent of the power generation of like England or France every year.
Yeah. And the US every 7 years.
Yeah, exactly.
Right?
Yeah. And they're at 2x now. So it's like, how are you going to match that? If electricity turns out to be the fundamental component that gets turned into intelligence, how are you going to match that?
Yeah. I don't want to go too far astray, but I wrote an essay titled "The Moon Should Be a Computer," which I freely admit is speculative. There's a lot of assumptions I had to make in there. What's not as speculative is that, if you increase the amount of energy consumption on Earth by a lot, I'm not saying a little bit, by a lot, by 2 orders of magnitude, you do start to have thermal effects that affect the atmosphere. And I kind of use that as an excuse, but the real reason to do this, honestly, is because you just can't get the put on the base grid loads power supply in the U.S. fast enough, because who knows why, regulations, or you just can't build it enough, or there's some kind of there isn't the competency to do it. But I kind of speculate like, hey, can we do this in space, or maybe in fact on the moon? And I thought this was a kind of idea that came about through chatting with one of my friends in San Francisco, who's now at Anthropic. But I thought, okay, this is a crazy idea. I knew, people would say it's a crazy idea, but actually some, really, I will not name names, but some really like important people read it and thought that was, a good idea. And I found out later that Eric Schmidt, of all people,
Yep.
is now, through some special financing, is now the CEO of Relativity Space, which is another YC company. My company is a YC company, so he's now the CEO. And one of his purported aims or reasons for, doing this is he wants to put compute in space. I don't know that he wants to put it on the moon, but he wants to put it in space. And I think one of the reasons, again, is regulatory. Like you just literally cannot get the energy
Right.
on Earth.
Sorry,
not on Earth, but in the US.
In his space project, would the energy actually be coming from solar panels, or is there a reactor that's in space that's orbiting?
I believe, I don't know that I've tried to find out, and if someone knows, please reach out to me actually, because I'm very interested in this.
Yeah.
But I believe solar. I don't think you can do nuclear in space because it violates so many
treaties.
Yeah. If the rocket went off, it would technically be a dirty bomb, and you don't want that. So I think it has to be solar.
But wouldn't you need like a kind of like a square kilometer of solar panels in space or something?
Yes. It is pretty nuts. Like I think for it to be, I tried doing the math on this, and I could be wrong, but I believe to get like a gigawatt, you need, is it like a square kilometer, or is it more like 10 square kilometers?
I'd have to check the math, but my intuition is that it's a lot of lift to put all that stuff in orbit, right? So
it is.
Yeah.
And to put it, and you can't put it in low Earth orbit, because if it's 10, let's say it's 10 square kilometers.
Yes.
It would literally, I did the cross section at some point.
Yeah, the astronomers would be a little mad at you.
Yeah, no, it would be, everyone would be
That's
mad
what I'm saying. Yeah.
So you'd have to put it in like an Lagrange point.
Yes.
Thankfully, there's a lot of space in space. So.
Yes. Okay, let's go back though to your experience. So as a startup founder, so your company was called Mutable, and you ran it for 3 years as founder and CEO. And I believe that it was in the space of basically AI tools for coding. Is that the right category?
That's right. Yeah. So I started the company in November 2021. I quit my job, and 2 weeks later, I was inducted into Y Combinator as solo founder. And that was a pretty brutal experience, but amazing, I should say, like one of the best experiences of my life. I basically did nothing but work. I didn't sleep. So because I had nothing, I had no code, nothing. I just coded all day, went to the YC, they have this curriculum basically, and then pitched investors. I managed to build something that, it doesn't matter too much, but it was something that cleaned up your Jupyter Notebook code with AI. I got one customer, and I raised a seed round.
Right.
So it was kind of most intense 3 months of my life.
Right.
But yes, I was one of the first AI developer tool companies. We came out around the same time as Copilot.
Right.
And the space is it's bananas now. Like Cursor is making Cursor is an AI development tool, is making over 100 million ARR. A bunch of these companies now are making over 100 million ARR, and very quickly.
Yeah. Now, you're too modest to claim credit, but I know Mutable pioneered a few things now that are kind of common now. And I think Karpathy gave this keynote recently that was on YouTube, where he talked about some of the ideas. I don't think he credited you, but I think you had these ideas, things like using the context in a certain way for software, or actually creating much better documentation, Wikipedia style documentation from the code base at a company. Yeah, I think you guys did a lot of interesting things at Mutable. Maybe you want to talk about that.
Yeah, happy. Yeah, I'm not too much to stand by the claim that we definitely invented a lot of the ideas behind probably the most popular manifestation of it today, called DeepWiki, from Devin aka Cognition Labs. But basically, I had an idea, and at the time I was in Austin, of looking at all these open source code bases, because I'm a very hyper curious guy. I've always been that way. And I always come across papers and code that I'm interested in. And, you can get pretty far, and you can develop the skill and muscle memory to onboard a new code base quickly, but it's always, kind of a slog, right? So I was like, why doesn't the AI just help me with this? Like, why doesn't the AI, let's say, write something like a Wikipedia article,
right,
to explain this code for me? And, what's a good name for this? AutoWiki. So that's what we did. We do this for big recursive summarization to explain your code. But the backstory is actually a little bit more interesting than that. And I think this might be useful for people who are founders or aspiring founders. So YC always likes to say, scratch your own itch. That might not be a direct quote, but something like that. So at least you have one user, which is you, right? So I built the initial version of AutoWiki myself. And at the time, my team was doing something else. It doesn't matter too much, but we had another kind of product with an active pilot. And I looked at the first version, showed it to my team, and they were like, this is whatever. And I remember looking at it, I was like, okay, this is not that good. So I kind of tabled it for a month or two. And then I had the same problem again. Okay, cool code base, cool new code base. I really would love to, onboard this code base quickly. So I was like, you know what, let me dust up my AutoWiki code. I don't even know if I'd called it AutoWiki at the time. And I did some improvements. I spent all day. I was just too curious. I had to. And lo and behold, at the end, I looked at the final kind of wiki, and I was like, you know what, this actually is useful, and it helped me understand this code. So it's useful to me. It's probably useful to others. So I showed it around the team. The reception, I wouldn't say was very strong, but it was much more positive. And then, at some point, later, and I kept kind of chipping away at it myself. At some point later, we decided, let's commit to this. Let's actually commit to this. And we launched it in January 2024, hit the front page of Hacker News. There were people reaching out from college, from my past, that, we're pretty viral. And yeah, that was kind of, we decided to put the full focus of the company, 100%. We actually kind of fired our customer. We were, we were, very nice about it. They were gracious. We came to some kind of agreement, but we put our full focus behind that. And it turns out, so that's kind of the backstory of like the development and the product ups and downs, which I hope are interesting. Is an interesting intro for startup founders or aspiring founders, like I said. But the technical part that's most interesting actually is what Karpathy mentioned in his talk to Startup School, I believe, which is that turns out to be a very useful context builder, because LLMs I've gotten so much mileage out of thinking like LLMs. Actually, you should anthropomorphize the LLMs, because they're, in a way, they're trained after an image. They're trained on human data, right, and human experiences. So it turns out having these cliff notes essentially of your code helps the LLMs. One for retrieval. So people talked about RAG, like retrieval augmented generation, but also for the generation part, because having these summaries, in a way, we preceded or predicted in some ways the reasoning models, which do the chain of thought, reason first, and then answer your question. So having it write a book report first and then answer your question was very compelling. We got much better results out of a code-based chat. So we built the code-based Q&A system that didn't require you to put in, these are the files I want as context. You could just put in the whole code base. In fact, we scaled it up to the Linux code base, and it could answer questions about the entire Linux code base.
Let me ask you a few questions about that. So in the part where you build the AutoWiki, does a human have to go in and correct any problems before you then use it productively in further generation of code?
We had a feature that wasn't much used where people could, modify it, but you didn't have to. There were hallucinations.
Yes.
And I think some of that is solved. There's techniques to get around that actually. But it turns, even with the hallucination, it was better to have it than to not have it. And I did more light than heat.
Right. So even as a fully automated process, you basically had the model look at the code base, think about it, generate a persistent document, and then, so in a way, it's a little bit like reasoning, right? So it's generating this stuff, but then as it does other things for you, it's able to consult that reasoning that it did earlier, right? So I think it's great.
And there's actually a deeper, I'm glad you're a physicist, because there's actually a deeper physics analogy, which it's an imperfect analogy, but it was always in the back of my head. The renormalization group.
Yep.
So with the renormalization group, for those listeners who don't know, it's this technology invented by Ken Wilson to explain critical phenomena in physical systems, where you have, this, condensed matter system, with, and you're way more on top of the physics than I am. I'm far from my physics training. But what I remember from my physics training from Peskin and Schroeder, QFT, quantum field theory, you have these critical, you have these systems, it could be quantum field theory, it could be condensed matter system. and you have the microscopic physics, but you want to get to the macroscopic physics. You want to predict a phase transition. So you do the successive coarsening, which in the auto wiki scenario is successive summarization.
Yep.
And then you get to the the critical phenomena, which is, hey, like this is a code base about X, or this is a code base about Y, or here's the answer to the question, and so on. So that was kind of always in the back of my mind as an inspiration. And I know that was one of the topics you wanted to discuss.
No, absolutely. I think it's, the idea that you can depend on the model to start from the actual code base, but then describe it in progressively, maybe more human-like terms, and store that somewhere, and that's useful, right? That's an interesting idea. And it is like the renormalization group, different levels of description of the same stuff. I think other people who have just, in general, researched neural networks have often made this analogy as well, that, so for example, the first layers maybe detect features, and then next layers combine those features. And there's also a renormalization group flavor of how neural networks actually process information. But I met you in Austin, and I think you did this, I don't want to necessarily call it a pivot, but I think when I first met you, you hadn't committed to the wiki thing. And then I think later when we became friends, you told me, hey, I made this pivot. And so very cool. And tell us, what's it like for an AI founder these days? What's the vibe? Like you were based, at that time you were based in Austin, but then you moved to San Francisco. Is that right?
Yeah.
And so what's the vibe like? Like you're out of it now because you're at Google, but when you were a scrappy founder living in SF, I don't know if you're living in Bays Valley, what's the vibe like? How's it feel?
Yeah, the vibe in SF, there's this tremendous energy, I think. From what I hear, so some people differ. Some people say, oh, it still hasn't fully bounced back from COVID. But I think at least in the AI field, there's this tremendous energy. I think SF is like the ancient Athens of the Western world. It's small. There's 700,000 people. I think ancient Athens was whatever, 250K maybe people. But yeah, the smartest people are there, in my opinion. The most generative, more importantly, the most generative people.
Agentic people.
Yeah. The human agents are there.
The player characters are all there.
Yes, exactly. And I love New York I love Austin. I love SF. Those are my 3 favorite cities in the US. But I rarely learn new things, I have to say, in Austin or New York. But I feel like I'm always learning new things in San Francisco. And
to the point where it's a little overwhelming, or?
I mean, I'm kind of a junkie, but yeah, it can be. Like I was there recently, and I was at, there's 5 events, literally. There was this AI engineers conference that was an amazing industry conference, probably the best conference. That was, had all these people like, Greg Brockman and so on, really, but also just really good actual
people doing the work.
And there's, Y-Series, and there's a private event on, AGI, futures and so on.
Oh, you were at that one too.
I was at that one.
That's great.
I asked one of the, I love the person who answered this, but personally, but I don't know if I agree with the answer, but I asked one of the people who spoke, hey, how have the empirical developments of AI changed, your views of AGI or post-AGI futures? And he said, not at all. And I'm like, oh, come on.
And you were just like mentally, okay, discount this guy, reduce weight to close to 0 for this guy. But the reason I'm asking you about the SF vibe is because, for people who are not in AI specifically, or they don't live in that area, it's hard for people to really understand what the scene is like, right? It's how intense it is, where like everywhere you go, there's people talking about AI models or, post-training, RL, reasoning, it's chips, it's all encompassing. And on top of that, there's a philosophical layer where people are talking about AGI. What's this going to mean for the society? What's this going to mean for the existence of the human race? It's all super concentrated there. And I think as you leave that area, people don't really get it. People are like, why are you guys so into this AI thing? I like ChatGPT. I use ChatGPT, but they don't really get the intensity of what's happening in the Bay Area.
I think, there's almost like this fun where, there's these public events that are, hosted by different startups and VCs often who, for obvious reasons, they're looking for companies to invest in and so on. And then there's kind of another layer, which is, those events are good, but there's another layer, which are like founder dinners, which I often get probably the most value out of, where people host, private dinners, again, sometimes VC, sometimes different companies. And it's kind of a friendly thing, but it's also sometimes a recruiting thing or a funnel thing for VCs. And those events are really good because people, kind of share their war stories and then technical tips and tricks and so on. And then I think there's just all sorts of, there also is like kind of a vibrant, I wasn't as plugged into this, but there's like kind of almost like a party scene, actually, like SF house parties and just random, billionaire. You get immune to billionaire, you I'm sure already are at this point, but you really do get immune to it. It's like, so like you're a billionaire, everyone's a billionaire, but it's crazy the level of people there and the kind of the ideas. I also think there's a lab scene as well. Like if you're in one of the labs, you tend to socialize people in the labs, but I think there's a lot of cross-pollination. And I'm not the first to make this observation where people live in a house and there's literally, one person from one lab living with another person from another lab. And you're like, hey, how do they expect it? I mean, I'm sure everyone's careful about their, the confidentiality. And I'm personally very serious about, any agreements like that, but it's hard not to.
Diffusion.
It's hard.
Can't be limited.
Yeah, I can't imagine, that knowledge doesn't get out somehow because humans, even without people violating their confidential agreements, like, just subtle intonations or what have you. And also people job hop, right? And my impression, and again, for the purposes of our conversation, I'm excluding Google because I don't have opinions about Google because they're my employer and, views here are my own. Sorry to make the incantation.
Yeah, no worries.
Like the Orthodox priest with the,
yes,
warding the evil spirit away. But I think I'm very much under the opinion that all the labs, again, including Google, which I'm not sharing my opinion on, basically they're doing the same things. I don't think that there's too much novel IP, or even if there is something that you could write on a napkin, how valuable is that? If like it's something you can write on a napkin, it's going to get out. Right?
So I love that. Okay. I love where you're taking this conversation because obviously, yes, there's going to be tons of diffusion. And like, imagine you're very curious or stuck on some particular issue in your own work. And say you're at lab A and your housemate or some guy that you meet, or you're at a party with your housemate and like, you meet your counterpart who's solving the same problem or in the same domain at lab B. How can you resist like actually just saying like, are you guys finding X, or have you looked at Y? Like that stuff has to happen, right?
I actually think they really read them the rights. I actually do think, and I don't know, at least maybe I'm just projecting my how I behave. Like I'm a consummate. Yeah, I really am. I'm just
right.
Like,
you stick to the rules.
I stick to the rules. My impression of people I talk to at the labs, they're also very careful actually because they really read them the rights.
Okay.
But so I don't think there's any like thing flagrant or that they're.
I didn't mean flagrant, but I meant like soft diffusion.
Soft diffusion happens,
and it could be like not directly from a guy employed by A to B. Like A tells his friend he went to grad school with, and the friend tells somebody else, and it gets to somebody at lab.
But
B.
even something as innocent as this is a cool paper, or something.
Right. Yeah. Oh, that doesn't work at scale.
Yeah.
Like, how do you know that? Like, did you guys try it?
Yeah.
That doesn't work when you scale it up. But related to this, so I think your thesis was just primarily though that there aren't big secrets.
I don't think so.
Okay. So then what is Mark Zuckerberg doing paying $100 million for an individual? What is he getting from that individual? Not secrets. Are there differences in capability that manifest at that scale?
Yeah, I can't speak for Mark, and I don't know how confirmed the 100 million stuff is.
Some big number. I think that they are reporting he did steal a handful of really good people from OpenAI. I think that is confirmed.
Okay, yeah, and anyway, yeah, I do think that there's some probably companies' outcomes are parallel distributed. I like to joke for my own case. I won't go into too much detail for obvious reasons, but like in the movie, I always like bringing up this movie Glengarry Ross just because it's a hilarious movie, right?
Yes.
And it's like the first prize is a new car, second prize is a set of steak knives, third prize is your fire, fourth prize is your fire, and so on, right? So like I got the state bias, right? But I think there's something like that with people as well. Actually, like I don't think the normal distribution is actually a good predictor of outcomes. I think there's something about people's capabilities, kind of like an airplane, where maybe you have a good engine, but if you don't have the wings, or if you have the wings but you don't have the engine, you can't take off. So there's something like that with people. So maybe to Steelman Mark. Maybe there's something like that with, just paying top dollar for people at the tail ends, maybe.
You might be interested in, there's some articles, quasi-academic articles with titles like how normal distributions are transformed into power law outcomes.
Mm-hmm.
So even though the individual people have power law distributions over their abilities, the way it interacts or nonlinear reinforcements in the system, you end up with power law outcomes.
Mm-hmm.
And so I think what you're saying has some theoretical basis, actually.
Yeah, we see this. We definitely see this with like founders, where like you could be an amazing technical founder, right? But if you don't have good communication skills, it kind of kills you, honestly. Especially in my opinion, in the West.
Yep.
It just kills you because like the VCs are not technical.
No,
usually
it's all vibes.
It's
but is it all vibes with Mark and building his super team for super intelligence?
I don't want to opine. I think Mark, I think Mark is a really strong founder. I think it's really gutsy. It's something only a founder CEO can do with like the super voting shares. I think the jury is still out. I'm optimistic, actually, I would say, but
I'm not questioning his making the bet because his engine throws off so much cash. Visors, meta worlds, like this is not the dumbest bet. Not the dumbest bet that he's made with his spare cash, right? So just betting on ASI and just building the best team. And plus, I think he's just personally interested in it.
Mm-hmm.
Like if I were Zuckerberg and I had his resources, I'd be like, well, why not assemble the best team that we can with our spare cash flow, and like why not have it here? And so I'm not questioning that strategic decision. I'm questioning like if you're going to allocate 100 million to get quote the best hires, is that the strategy? Like maybe you just have to do that. You could argue because there's only a limited number of people who really know their shit.
Yeah.
But the opposite thesis is no, there are a lot of people who know their shit. So
yeah. So this is good. Yeah, because I didn't really answer your question. Like if I'm saying there's really no secrets, then why pay top dollar for these people?
They're not completely contradictory, but there is a little tension there.
There is a tension there. Yeah. It's very hard for me to say, but I will say that even if there aren't secrets, there are, or in my opinion, at least really compelling secrets that you're paying for. I don't think you're paying for the secrets, but you're paying probably for this tacit knowledge where there are these subtleties that come up in building these, and that you don't want to maybe wait for someone to up ramp. And maybe from his perspective, he tried that. And, Llama 4, I don't want to speak ill of them because...
Oh, you're so careful. You alphabet dudes are so careful, but...
It's not just because I'm so careful. It's because I know how hard it is to build something. And I don't like criticizing builders as a rule. Like, I think builders are like heroes. And like, I think it's just easy to criticize from the sidelines. But yeah, I think that even that team would say Llama 4 wasn't the best, showing, right? So I think for it, it is worth like, this is serious stuff. Like, look, AGI is happening. Like, that's what I believe, at least. It's happening soon. So like, he can't miss out on this.
Right.
So he's better off overpaying than missing out.
Right. You could just say like, look, so what if he overpaid? He can afford to overpay.
Yeah.
My interpretation would be at the level of what is meant by there are no secrets. It means like A kind of knows what B is doing, or at least knows the range of things that B is doing. So there's no secrets in that sense. But some guy has exquisite taste and he just has a nose for like, well, we should try this first. Or we've tried this for a while and it hasn't worked, but we should throw more resources at it. Those are all subtle, nuanced decisions, right? And it's not a secret. It's like a subtle judgment call that someone has to make. And maybe one guy makes that better than the other guy. A little bit like trading too, like in finance, you'd have a similar situation. But I think that's a possible justification for the $100 million comp package.
Yeah.
So, I mean, you'll see the same things at hedge funds where there's somebody gets like an enormous comp package based on some past performance, but who knows how predictive.
Or people say the same thing about CEO pay, right? Sometimes in the more popular discourse, right? Yeah.
Right. I guess I on the one hand, I feel a little FOMO, but on the other hand, I feel like it's good that geeks are getting paid like that. Like, shouldn't a geek get paid more than Ichiro Suzuki or, or Tom Brady? They should, right? Give them the money. So yeah.
It'll be interesting to see what people do with their money.
Yeah. Well, it all feeds back because a lot of like billionaire type people are very willing to fund science philanthropy. Like for them, it's cooler to say like, oh, I helped Caltech build this telescope than like, oh, I just bought another 1,000 square meters worth of house, in Miami or something. They're not that into that stuff. They're more into like putting something into something really cool. So I think just as we were saying, these people are agentic and smart. If you give them huge resources that they don't really need to live, I think they'll recycle them in interesting ways. They might fund biology research, and they might fund some research that's really valuable.
I hope so. I am a little skeptical. I think it's true in some cases, and I certainly have friends. You and I have friends. I think almost like I hate to psychoanalyze you on the spot, but I think you're going to tend to attract the most interesting segment of people who make like tech money.
Yeah.
Who do this like kind of agentic and interesting stuff. But I actually think that's not the norm. Unfortunately, I think people do just kind of retreat into their shells. There's not enough Medici. So like, well, I hope you don't mind while I'm on your podcast, like I will kind of opine that more people who make tech money should do more interesting stuff with their money. Like, for example, like the Vesuvius project, like it doesn't have to be philanthropy. You could just do interesting stuff.
Yeah.
Just do something interesting. The guy, I forget his name, who confirmed that the site of the Iliad really existed, like ancient Troy really existed, just had an idea in his head. Like, I'm going to go to this, part of Turkey. I'm going to go dig out this site. And I think that's where Troy is based on this evidence, right? Like more people should do stuff.
Well, I totally agree with you. I mean, also being a professor, I'm the guy with the begging cup trying to get the wealthy guy to like fund some academic science, right? So I 100% agree with your thesis. I do think that the kind of guy that Mark pays up $100 million for to help build AGI or ASI is probably the kind of guy who has these broader interests, like interest in science and stuff like that. So on average, compared to a guy who just like runs a macro hedge fund here in New York. And what's he going to do with his money? His wife is going to collect a lot of art or something, right?
It's almost like we've lost the ability, people talk about it, not to stay on this topic for too long, but, people talk about, throw around all these buzzwords, but like, and I'll do a little bit of buzzwording myself, but, aristocratic tutoring or like taste. You spoke about taste earlier, or mentioned taste earlier. We just don't develop this sense of, adventure and, I don't know what it is, adventure or culture or like agency in people. You can be very successful in one domain. And then once you collect your earnings, you just don't use it, at all to do something
very typical.
Yeah. Anyways, well, enough about that, but yeah.
Well, I agree with you. Okay. So let's come back to one topic we said we were going to talk about, because this is part of your role now, is agents. So if someone comes to you and says, I'm on social media. Every day I see some clip of some guy's agent that, can do everything for me. But nobody I know actually gets much value out of agents right now. So where's the dividing line between hype and reality for what agents are good for?
Yeah, no, good question. I think, look, it's just really, this field is moving very fast. And I think it takes time for these developments to spread. I don't know if I'm a full Tyler Cowen-esque, he has this whole thesis, which I want to explain briefly about how this is akin to electrification. And it's going to take 100 years for AGI to diffuse into the economy. I think that's too slow. I don't fully believe that. I get where he's coming from. There's regulatory hurdles. There's like people just take time to change their minds and change habits and so on. Who was that physicist that said, physics advances one funeral at a time?
Maybe Heisenberg.
Was it? Are you sure?
Well, yeah, because it's somebody in that group, because the thing that historians never say is like all the old guys pre-quantum revolution didn't believe quantum mechanics, and like now we don't even think about that. But even that transition was a rough transition.
Yeah, I think there's actually something similar happening with AI. You see this sometimes with some of the old school software engineers that just still don't believe in AI. And I'm like, really? Really? Anyway, so I think there's something like that. There's probably something like that that's going to happen with different industries, but I want to directly answer your question. I think undoubtedly today, there are software agents, which I work on. And again, sorry, I'm doing the alphabet thing. I want to be very careful when I comment on my actual work, but I can talk about the field freely. I think that's clearly like a thing. People are using Cursor, people are using Cloud Code, and so on. All these other tools, right? It is making a big difference in their day-to-day, software development. People are, and I saw this even, in my time at Mutable, running Mutable, that the standards for software, even for a startup, are much higher now. You just can't have shitty software, even if you solve like some unique novel pain point. Customer expectations are very high, and that's going to pull the field forward. So I think that is happening in software. Other domains, I agree, it hasn't fully happened, but we see a little bit in the legal domain. Actually, Harvey supposedly, and other companies like that, they're making a lot of money. There's a few other domains like that, and I think slowly but surely, or sorry, actually not even that slowly, we were going to see, white collar labor get these software agents, and I don't know what it's going to do to people's jobs, but it's definitely going to help with the development, if not take over the development.
Okay, sharp question. So I think it's reported that for the graduating class of 2025, people with computer science, software engineering training, the job market is poor. There's been a decline in offers, or the increase in the employment rate. How much of that is due to AI-driven improvements in productivity? How much of it is just like big tech not hiring as many people for some other reason?
It's hard to say. I would bet currently it's more that the tech companies are not hiring as much. And I think there was like this very ZERPy era where you would, make a job offer to anyone, anyone basically with even halfway plausible. And I think that was unsustainable, and probably that led to at least a short-term belt tightening, because there's just an overhiring spree. And even if you have layoffs, people are reluctant, for very human reasons and other reasons, morale reasons, to do cuts that are too deep, right? So they're probably companies in general overhire, and they're not hiring as much. I do think that there's something deeper going on, though. I think that is a cop-out a little bit when I say that. I think there's something going on with a combination of AI and the computer science curriculum, where the computer science curriculum is kind of weird. I know they've changed it from what I hear, but basically they're learning, discrete math, they're learning algorithms. They're not learning actual software engineering. So often a green CS grad won't actually be that effective as a software engineer. He or she will just not be that useful to you. And that's kind of why I personally didn't hire that many people who are newer. I did hire, and I'll tell you the exception of who I hired. And maybe this is, if there's younger listeners, because I am interested in helping out people, other founders, and perhaps if there's people who want their first job in the field, try to give a little bit of advice here. I did hire a 19-year-old, and that person, didn't go to college, actually. They just had graduated from Princeton High School. And they did a bunch of robotics projects. They did a bunch of Rust projects. And I could tell, when you talk to someone, their power level, okay, wow, this person's power level is very high. So there was something about that person that I hired that I could tell was amazing. I wasn't sure. Of course, I interviewed them, and they did really well in the interviews, and I made that person an offer. So that just goes to show you that it's really, I do think employers will hire you especially startups, especially YC startups, like work at a startup, will hire you if you can show competence, if you can build things, if you have projects, and kind of just go build things. Just go build things. That's almost more important than the degree at this point. And it shows agency more, and I think agency is going to be more and more important.
Right. So that's advice to young people, but just to pin you down on the answer to my question, I think you landed in the safe spot, which is there are multiple explanations, multiple factors contributing to the decline of offers to software engineers in 2025. Part of it is post-ZERP era, that companies overhired and they realized they were bloated and they're shrinking in the higher interest rate environment. But part of it is also a recognition that there's some increase in productivity from AI tools. Is that? Is that
Yeah,
fair?
I think so. I think there's definitely a part of that. If I had to guess, that's double digit effect at least, because right now the AI can do a lot of the work of a junior engineer, and the job is kind of moving toward being like a TLM or a TL, where you're managing these teams of agents, kind of.
Team leader.
Yeah, team
Yeah.
leader
Yeah.
or technical lead sometimes.
Yep.
So like, do you need a junior engineer anymore? Maybe not. And then the junior engineers were always probably actually a net negative in the short term.
Yeah.
And it was always something you did like, oh, I'm growing my pipeline. I'm hiring this person not because they're going to really actually help me that much. And actually, they're going to maybe be a net negative actually beginning in the first, maybe even in the first year or two. But I need, to grow my pipeline. I need to keep up. So maybe there's a feeling like you just can get by with much less. And I think I'll point out two people. One is more kind of more in agreement with what you're saying, Dario Amerde, who's saying, hey, like there's going to be massive job loss in 2 years actually because of AI. I have a standing bet actually with a friend who works at Anthropic. We put it on both of our calendars almost exactly 2 years from now that he predicts that there's going to be, like at least 30% drop in layoffs in, tech companies across the board, including companies like that are leaner already, like Tesla, let's say. So we'll see. I mean, I made the other side of the bet. I think 30% is too high. But even less dramatic than that, there are people like Toby Lutke, I believe, the Shopify CEO, who he didn't really opine on layoffs as much, but he did mention, that he expected all of his teams to use AI more and to see how much they can do with AI without hiring more people. And you hear about companies like Quora where like they're hiring someone just to like automate as much as possible of what they do with AI. But there is a sense that AI will just make you more productive and you can get by with less and less people, and then therefore you don't need to hire as much. But then that goes back to what's that economic law again? The Jevons paradox that people throw around.
Yes.
So who knows?
Right.
It's so hard to predict. I don't have a good answer. It's so hard to predict these things.
Okay. Now coming back to the word agent. So I think you mentioned a few cases where it is clear that there's a productivity gain from AI tools. But I want to differentiate between AI tools where you send a query in to ChatGPT, or you ask ChatGPT to revise something or write a first draft of it. I don't really think of that as an agent. I think of an agent as something that's a little more autonomous and takes multiple steps autonomously without human supervision, as opposed to a one-shot or a few-shot tool where the human is looking carefully at everything that comes out. So what's an example where, I want to write some function in my code base and I just let the agent go hog wild and it does a bunch of non-trivial stuff and returns it. And, is that a real thing now?
Oh, absolutely. Yeah. All the examples I mentioned have true agents in my opinion. So like you can, in the settings of all of these tools like Cursor or whatever, and honestly, any of them, Lovable, whatever, put the setting so that you don't have to affirm, like confirm all the actions.
Yep.
And you can just let it go hog wild and way more than a function. You can have it build like a feature. You can have it build a web app. You can have it build, and I think it works decently well. I think there's an argument to be made that the argument people usually make is like with increasing nines of accuracy, the set of things it can build that require more steps to build, so you're multiplying the 99.99.
Yes.
So, it's going to just improve the kind of the horizon, the time horizon and the sequence horizon of actions it can take. And therefore it can build more sophisticated stuff. And often that's, by the way, used as a justification for why are people spending so much on, AI data centers, chips, energy, because scaling laws, people often portray it, maybe it's just my perception, but as like some kind of free lunch, like, oh my God, this is an amazing thing. But actually it's kind of terrible, right? It's a logarithm. Scaling laws are a logarithm.
Yep.
And I think the only way you can justify it is, this kind of the increasing nines argument, but also, and maybe this is a nice physics connection, is the emergent abilities argument that maybe, there's a scale at which, going back to the airplane analogy where you have it looks like an airplane, it smells like an airplane, but it's not, not an airplane. It doesn't take off, and then you go up in order of magnitude and, oh, wow, it takes off, it's an airplane. So I think there's going to be like things like that. It's very hard to predict though. And I think scaling laws, by the way, are one of those things where I have this, hobby horse almost of like, scaling laws are like thermodynamics. where we discovered thermodynamics and steam engines way before we discovered statistical mechanics.
Yep.
So as an open question to other AI, researchers and people in the field, what are the statistical mechanics to scaling laws? Because I've seen stuff, and I've asked you this question before. I'm not quite satisfied with the answers. I think there's something deeper there, but I could be wrong.
Yeah, we've talked about this before. I think when for people who are in a little more relaxed situation where they're not trying to ship, the next version of Claude or something, and they have a little bit more of a theoretical bent, I think you're going to see people coming up with more fundamental models that then explain particular scaling laws that we're seeing. I think that's what you're searching for. But I haven't yet seen anything quite of that nature. But I do see papers where people are trying. So I think eventually there will be some better understanding of these scaling laws.
Yeah. I think just to give maybe a more concrete example, so Tim, I think Detters, I can't remember.
Detmers. Is he the quantization guy?
Yeah.
Yeah, I had him on the podcast.
Oh, nice.
Yeah.
Nice. Okay. So like that, just to review some of his work, I believe he showed that after 7 billion parameters and many families of language models, that there's these outliers that emerge. And there's a phase transition, and physicists are obsessed with phase transitions, right? Because they happen all over physics. They happen in particle physics, they happen in condensed matter physics, and so on. And they happen even in galactic physics. So, I heard an interesting rumor that, other groups, this is in Google, of course, but other groups, one of the other labs was not able to confirm actually his results, by the way.
Interesting.
Yeah.
Not able to replicate.
Yes.
Interesting.
So who knows? But
yeah.
More things like that, like come up with these like quantitative measures, ideally, not just based on benchmarks. I mean, those are a bit too of like emergence.
Right.
And then like, could you predict those? Is there like a stat mech for this? Is there a way to predict these?
Right.
Or at least, a lower, relatively low parameter way of predicting it.
One drum you'll always hear me beating on X is about open source models, because for someone like you who has access to the whole Google Alphabet infrastructure, you can, if you get interested in something, code it up and run experiments, quite easily. But for academics, the existence of, these small open source models like Qwen and DeepSeek or Distilled DeepSeek are super important. When you look at the papers, someone has some theoretical idea, they do some theory, and then they do a bunch of calculations using open source models to verify, that the behavior they theorize about is actually empirically observed. And that would be impossible actually if these, because sometimes they have to modify the models in some way, or, they need it to be really open source actually. So I actually think for this theoretical investigation, it's really important that academics have access to open source models.
Absolutely. Yeah. I've seen so much interesting work, especially recently on RL, reinforcement learning, on these models, like Qwen and DeepSeek and so on. Yeah.
Okay. We're near an hour. So what's a topic that I didn't ask you about that you'd like to opine on?
Yeah, I mean, maybe two. One we commented on briefly, and another one that is another one of my kind of topics that I go back to. So one is like, what is the role of physical intuition in AI?
Oh, great! Yes, we were good. I'm sorry, we said we were going to discuss this. I forgot.
We did touch upon it though. The normalization group and so on. So I think that there's something to be said. And before I go into the direct arguments, let me give kind of some of the social proof, quote unquote, on this. If people didn't know, a lot of the developments in the field have been made actually by ex-physicists. And, Steve and I have to, we have to pip the physics.
Was it Ilya or was it Karpathy recently who just tweeted out something like, theoretical physicists are like the stem cells.
The embryonic stem cells. I've now seen them become everything.
Yeah. Who was it?
It was Karpathy.
Oh, it was Karpathy. Okay, yeah. But it's totally true. I mean, just historically, it's true, right? That okay, you can build bombs, you can design microchips, you can solve problems in biology. Theoretical physicists have done all that stuff in the past, so it's not surprising they could make some contribution in AI. But my question for you is, what is the special intuition or capability or advantage that theoretical physicists bring to this field in particular? And also, what are the blind spots? What are things that theorists or physicists are weak at, where maybe the CS guys bring more strength to it?
I actually can answer both, I believe. So physics, unlike math, Physics is honestly like, it's almost like you get everything that a mathematician does, and mathematicians might not like to hear this, but it's true. And you get this physical intuition, which some mathematicians have. Like I actually basically did a double major in math. That was whatever I had off by course. And then, but like, I think real analysis, like I took a bunch of real analysis classes in undergrad, and there is a kind of something that feels like physical intuition with the epsilon delta proofs. That's the closest I think mathematicians get. I think sometimes geometers, there's not that many geometers though, in my opinion. I think a lot of mathematicians are, there's a lot of algebraists. Topology isn't really give you the physical intuition. But anyways, physical intuition, this movie that plays in your head, at least there's a movie that plays in my head that's super satisfying that I see when I do physics problems or I read physics textbooks. That intuition carries itself to AI research very directly, because loss curves are like an energy manifold, basically, where you have, this ball rolling down the hill and you're trying to optimize this manifold, right? And like, there's so many analogies between information theory and like KL divergences where it looks like, again, a literal Hamiltonian, right? Where you have partition functions. You have all these things in physics that not only are analogous, but they basically exactly.
Well, after all, the word entropy does come from physics, right?
Yeah,
so
yeah.
you open a theoretical AI paper, and the word entropy is going to appear there at some point, right? So, yeah.
Yeah, I think there's just too many opportunities where there's something happening where there's a physical process almost where they're, having a physical intuition for how that moves and unfolds is helpful. I also think like familiarity with the kind of math, actually, the like, path integrals, I mentioned some of the other math, stat math, partition functions, more continuous math, dealing with continuous math, applied math, dealing with approximations, I think is all very helpful. And that's why, you have people like Jared Kaplan, I was reading his, some of his string theory papers. And then I love to tell a story because it's so funny. I was reading another Jared Kaplan's papers in AI. And then a year later, I was like, wait, it's the same person. So there's something there and in terms of the weaknesses, and I experienced this firsthand because like, I was really a physicist. I didn't really I was trained as a computer scientist. I think some of the like very like algorithmy stuff with like, there's subtleties with like some of these algorithms and like for loops, and you put the bit here and there, and then, oh, actually you didn't account that the bit was shifting this way. And, you can learn that as a physicist, but it's not your bread and butter. So that's definitely a weakness. Some of the more traditional CS stuff.
Yeah.
You're just not trained in it.
Yeah. But I agree with you completely. The discrete algorithmic stuff is not necessarily our strength, but on the other hand, we're better at dealing with continuous systems. And I think when you get to enough parameters and enough, quasi-continuous values of those parameters, it becomes a continuous optimization problem, not a discrete optimization problem. So it sort of shifts it a little bit more toward physics intuition.
Yeah, the tension between continuous and not to open another thread, but the tension between continuous and discrete math is super fascinating. I think it's a tension that's a rich source of mathematics and physics. And in physics, we of course come across it all the time with like, we have the wave particle duality, and we learn later, everything's really quantum field and so on. But you have these manifestations where like you have things that are very discrete, like Ising model, Ising systems, but there's like, ways of thinking about these that are, in limits that become like very continuous and so on. And so I think it's a very, very rich tension, but physicists do actually deal with discrete phenomena.
Now, not to put you on the spot here, but as advice to Zuck, should we throw some of these $100 billion packages at former theoretical physicists? What do you think?
I think so. Yes.
Can only help, right?
Yes. I mean, there's a reason why, Anthropic, so many people there are, there's even people like, I think a mutual acquaintance or friend, John Schulman, I think he did an undergrad.
He was an undergrad physics major at Caltech.
Yeah.
Yeah.
And Carhathy was an undergrad physics major. There's tons and tons of
yeah. The other thing about physics is that the math you learn is specific to the most useful, interesting problems that humans have encountered. So it's like biasing you toward not the math that's most interesting to pure mathematicians, but the math that's actually most directly related to real world systems that people have gotten control over, right? And so it is the right curriculum for whatever other thing you're going to do in your life.
Yeah.
Great. Well, that's a wrap, I think. And I want to thank you again for being on the show. I'm sure that there's some young guy out there who really was stimulated or appreciated your insights in the conversation. What's the best way for people to get in touch with you?
So you can go to my website, omarshams.ai, and all my contact information is on there. You can follow me on X, which is my handle is Omar Shams backwards, right to left, and or my email is on my website as well. So feel free to reach out.
Okay, we'll put some of that in the show notes.
And thanks again for having me.
Yeah, we're good.